Good day, PED students. In our last topics, I believe that you have already learned how to perform the four fundamental operations on rational numbers, and also you've learned how to perform those operations by using visual models. Now, in our lesson today, uh, you will be able to convert complex fractions to simple fractions and solve equations involving rational expressions. So basically, we will be having two subtopics for today. So I hope you're ready for a new discussion. Now, let's begin with our first topic, which is complex fraction. By definition, a complex fraction is a fraction where the numerator, denominator, or both is a fraction. It is a fraction of fractions. Uh, this here, these examples are actually complex fractions. For the first example, we have 1/2 over 7, in which the numerator is a fraction, and then 5 over 7 all over 3/4, which is a complex fraction because the numerator is a fraction and also the denominator. The same with this example, 3 plus 7 over 9 all over 9 minus 3 over 4. That is also a complex fraction, and I believe it is very visible. Why? And then also, lastly, we have 8 over 4 minus 3 over 7, which is also a complex fraction. Now, let's learn how to convert complex fractions to simple fractions. We can simplify complex fractions by employing the methods of adding, subtracting, multiplying, and dividing fractions, which you already have learned previously in our lessons 4 to 6, the four fundamental operations on fractions. And we are going to use that in converting the complex fractions to simple fractions. Let's have this word problem here, which you can see from this side, and you can also check this side for more word problems involving complex fractions. And this is an example. So we have here a cookie factory uses 2 over 9 of a bag of flour in each batch of cookies. The factory used 4/3 of a bag of flour yesterday. Now, how many batches of cookies did the factory make? So in order for us to solve that one, that is actually just equal to 4 over 3 all over 2 over 9. So we can interpret this one here as this one. So as you can see, this is a complex fraction in which 4/3 is the numerator, which is a fraction, and 2 over 9 is the denominator, which is also a fraction. Now, divide this by taking the reciprocal of 9. That means we have to get the reciprocal of the divisor or the denominator, and then multiply it by the numerator or the dividend. So 4/3 times the reciprocal of 9, which is 9 over 2. And then multiplying these fractions, we'll get 4 times 9, we have 36, and 3 times 2 is 6. So simplifying 36 over 6, we'll get 6. Therefore, the cookie factory made 6 batches of cookies yesterday. So that is the solution for this problem. Now, let's have more examples in converting complex fractions to simple fractions. First example, we have 5/7 all over 3/4. So we have to perform the indicated division. So this one here, this complex fraction is actually just equal to 5/7 divided by 3/4. Meaning 5/7 here, the numerator is our dividend, and then 3/4, which is the denominator, is the divisor. So in order for us to perform the division, we'll have to get the inverse or reciprocal of 3/4 and multiply it by the numerator. So 5/7, we'll just copy 5/7 and then multiply it by 4/3, which is the reciprocal of 3/4. And then we can now perform multiplication. Multiplying 5 times 4, we have 20, and 7 times 3, we have 21. And since this is already a simplified form of the fraction, then this is the answer. Meaning this is the simple fraction that is just equal to this complex fraction. Now, let's have example number 2. We have here 1/2/7. In this example, our numerator is 1/2 and then our denominator is 7. So our denominator is a whole number, and we can actually write that as 7/1 in fraction form, since dividing 7 by 1 is just equal to 7. And now we can divide. So 1/2/7 is just equal to 1/2 divided by 7/1. And in order to perform this one, in order to divide 1/2 by 7/1, then we have to get the reciprocal or the inverse of 7/1, which is just equal to 1/7. So we can proceed with multiplying or with multiplication. So 1/2 times 1/7 is just equal to 1/4. Now this is the simple fraction or the equivalent simple fraction of this complex fraction. Let's have example number 3. We have here 8/4 minus 3/7. So we have to simplify first the denominator, 4 minus 3/7. So as you have learned, in order for us to perform subtraction or addition, we have to get the LCD, since this here 4 is just equal to 4/1 and 3/7. So 4/1 and 3/7 has different denominator, which is 1 and 7. So in order for us to perform subtraction, we have to get the least common denominator or the smallest common multiple. So we have to get the multiples of 1 and 7 and then spot the smallest common to both. So the LCD or the smallest common multiple is actually just 7. Now, converting 4/1, we'll get, we'll have to divide 7 by 1, and we have here 7 divided by 1, and multiply 4, which is the numerator. And then we'll also do the same with 3/7. We have 7 divided by 7, this one, and then multiply 3, which is the numerator. And then just copy 8. Now this one is just equal to 8 all over 7 divided by 1, that's just equal to 7. And then times 4 minus 7 divided by 7, that's just equal to 1 times 3 all over 7. That's just again equal to 8 over 7 times 4, we have 28, minus 1 times 3, we have 3 over 7. So now we have this complex fraction, which is 8 over 25 over 7. In order to simplify this complex fraction to simple fraction, we'll have to rewrite 8 as 8 over 1. So here, 8 over 1 all over 25 over 7 is just equal to 8 over 1 divided by 25 over 7. And again, in performing division on fractions, we have to get the reciprocal of the divisor, which is 25 over 7. So its reciprocal is 7 over 25. So multiply 8 over 1 by 7 over 25. So in multiplying fractions, we have to multiply their numerator 8 times 7, which is just equal to 56, and its denominator, which is 1 and 25. So 1 times 25 is 25. So our answer is 56 over 25, which is just equal to 2 and 6 over 25. So this one, these fractions, these simple fractions, are the equivalent of this complex fraction here. Did you get example 3? I hope so. Now let's proceed with example number 4. We have here 3 plus 7 over 9 over 9 minus 3/4. Now we have to perform these operations in numerator and denominator simultaneously in order for us to get the simplified fraction or the simple fraction. We have here 3 plus 7 over 9, that's just equal to 3 over 1 plus 7 over 9. And also 9 minus 3/4 is just equal to 9 over 1 minus 3 over 4. Now let's have first the numerator, which is 3 over 1 plus 7 over 9. So we have to get the LCD of 9 and 1 in order to perform addition. So we have our LCD is 9. So we have to divide 9 by 1. 9 divided by 1 is just equal to 9 times the numerator, which is 3. So 9 times 3 is 27. And also 9 divided by 1, 9 is 1 times 7 is just equal to 7. That's why we have here plus 7. Now we can add 27 and 7, which is just equal to 34 over 9. So copy 9. So we already have the numerator. Now let's have the denominator. So 9 over 1 minus 3 over 4. That is just equal to 36 minus 3 over 4. So how did we get that? We find the LCD of 1 and 4, which is 4. So 4 divided by 1, 4 times 9, 36. And then 4 divided by 4, 1 times 3, 3. So 36 minus 3. which is just equal to 33 over 4. Now we already have this complex fraction, and converting that to simple fraction, that's just equal to 34 over 9 divided by 33 over 4. Now, in order for us to divide fractions, again, we'll have to get the reciprocal of the divisor and then multiply it to the dividend. So in here, our dividend, or the numerator of the complex number, is 34 over 9 multiplied by 4 over 33, which is the reciprocal of our divisor, which is 33 over 4. Now, multiplying these fractions, we have 34 times 4, that's just equal to 136, and 9 times 33, which is just equal to 297. Therefore, this complex fraction is just equal to this simple fraction, 136 over 297. So that's it for complex fractions and converting complex fractions to simple fractions. Now let's go on to our next topic, which is equations involving rational expressions. So what is then rational expressions? A rational expression is any expression that can be written as the ratio of two polynomial expressions. So in order for you to get a clear picture of what a rational expression is, let's let's write the following statements into rational expressions. We have here first the equation of 3x and the quotient of 3x and 6y. So quotient meaning we divide 3x by 6 over y, or we simply can write 3x and 6y in a fractional form, in which 3x here is the numerator and 6y is the denominator. So this is the rational expression for this statement, or for statement number 1. For statement number 2, we have here the quotient of 2a minus b and 7a plus 3b. So the same as example number 1, if we are given this kind of statement in which we are asked for the quotient of two expressions, the first expression will be automatically our dividend, and then the second will be the divisor. Or in fraction form, meaning the first expression will be the numerator, and then the second one will be the denominator. So the same as what we have done with number 1. In number 2, we'll write 2a minus b as the numerator over the denominator, which is 7a plus 3b. So this is the rational expression for this statement. Now, let's have number 3. The number of hours spent traveling is x squared plus 3x plus 2 kilometers at an average speed of x minus 1 kilometers per hour. So meaning kilometer per hour, meaning kilometers divided by the hours spent traveling that distance in kilometers. So we have here x squared plus 3x plus 2 divided by x minus 1. This is the rational expression for statement number 3. Now, let's try this one. The fraction whose denominator is 5 more than the numerator 2x. So meaning the numerator is 2x as stated in this one. So 2x is our numerator, and then the denominator is 5 more than 2x, meaning 2x plus 5. So this statement is just equal to this expression, 2x over 2x plus 5. And the next, the average speed in x squared plus 5 kilometers traveled in x minus 3 hours. So it's a common knowledge that the average speed is equal to the distance traveled over the hours spent or the time spent in traveling. So meaning x squared plus 5 divided by x over 3. So our numerator is x squared plus 5, and then the denominator is x minus 3. So now that you already know how to write a rational expression, let us solve some equations involving rational expressions. Let's have example number 1. We have to solve for the equation 2x over 4 equals 1/3. So meaning this expression here, 2x over 4, is just equal to 1/3. And our goal is to find x. Alright, so how can we do that? So first, since the numerators are, or the denominator of both expression in both sides are not the same, we'll have to multiply both sides by the least common denominator, or the LCD. And I believe you already know how to get the LCD of two numbers. In this example, we'll have to find the LCD for 4 and 3, and that is 12. So meaning we'll have to multiply 12 in both sides of the equation, meaning multiply it by 2x over 4 and multiply it by 1/3. So our 12 here, that's just equal to 12 over 1 in fraction form, right? So apply your knowledge in multiplying fractions. So 12 over 1, or 12 times 2x over 4, will get 24x over 4. Because we'll multiply 2, which is the numerator, by the numerator here, which is 2x, so 24x. And then the denominator in 12 is 1 times 4, so that's just equal to 4. Now, in the other side, 1/3 times 12, so we'll multiply 12 by 1, which is just equal to 12, and then 3 by 1, since 12 is just equal to 12 over 1, so 3 times 1 is just equal to 3. And now we can simplify both sides of the equation by dividing 12 by 3 and 24 by 4. So 24 divided by 4, we have 6, and then copy x, so we have 6x, and also 12 divided by 3, that's just equal to 4. Now, 6x equals 4 is just equal to x equals 4 over 6. So how did we get that? We divide both sides by 6. So 6x divided by 6, that's just equal to 1, or 1x, or just x. And then 4 divided by 6, so 4 over 6. And since this is not a simplified form yet, or this is not in the standard form yet, since that can still be simplified, we have to divide the fraction by the GCF of the numerator and the denominator. So the GCF of 4 and 6 is 2. So 4 divided by 2, that's 2. And 6 divided by 2, that's 3. So meaning the equivalent of x in this rational expression or equation, in this equation, is 2/3. That means that if we'll substitute 2 over 3 in x here, that will be just equal to 1/3. So I would like you to solve that in your seats or wherever you are right now listening or watching this video. Try if that this one is really just equal to 1/3 if we'll substitute 2/3 by if we'll substitute x by 2/3. And if that's just equal, then we got it right, that x is just equal to 2/3. That's example number 1. Now let's have example number 2. We have to solve for the equation 5x plus x over 3 equals 10. Again, just like how we solved the first example, we'll have to multiply both sides by the LCD. So since 5 over x is just equal to 5 over x, 5x over 1, and 10 is just equal to 10 over 1, meaning we'll have to find the LCD of 1 and 3 since those are the denominators present in our equation. So LCD of 1 and 3, that's 3. So we have to multiply 3 in both sides of the equation, meaning it multiplies 3 by 5x, x over 3, and 10. So 3 times 5x, that's just equal to 15x. Copy the operation plus x over 3 times 3, that's just equal to 3x over 3. And 10 times 3 is just equal to 30. Now, we can simplify 3x over 3 by dividing 3 by 3. So 3 divided by 3, meaning 1. So there's 1x remaining. So this equation here is just equal to 15x. We just copy 15x plus 1x or x. And then copy 30. Now, adding 15x plus x, meaning there are 15x plus 1x, that's 16x equals 30. Now, divide both sides by 16 since we want to isolate x. So we have to divide both sides by 16. So 16x divided by 16, that's 1x or x. That's why we have x here, equals 30 divided by 16. So this is the answer. Now, since this is not still in a standard form, we have to simplify that one by dividing both the numerator and the denominator by their GCF, or the greatest common factor of 30 and 16. So that's 2. 30 divided by 2, we have 15. And 16 divided by 2, we have 8. 15 over 8, or 1 and 7 over 8. So again, if we'll substitute x, the x's here in this equation, by 15 over 18, or 1 and 7 over 8, and perform the indicated operations, then this expression 5x plus x over 3 is just equal to 10. And then you may also try that one just like in example number 1. Now let's have example number 3, our last example for the topic number 2. So we have to solve this equation. Solve for x. 3 over x minus 5 plus 6 over x minus 2 equals 8 over x squared minus 7x plus 10. So again, in order for us to solve for this equation, we have to multiply both sides by the LCD. But since it will be hard to find the LCD if this is in this form, this one, the denominator of 8, will have to factor this denominator. So factoring x squared minus 7x plus 10, that's just actually equal to x minus 5 times quantity x minus 2. So this one is just equal to this. So these are the factors of this denominator. Now, having this equation, we can now get the LCD of their denominators and then multiply it in both sides of the equation. So by looking at the equation, we will know that x minus 5 times x minus 2 is the LCD. So again, ato ang i-times both sides by our LCD. And this one also i-times na to ani. Now, this one times 3. So that's just equal to 3 and then times our LCD. So dili sa nato i-multiply tanan. So ato asang i-amura na to isuwat sa iyahang kilid, no? So 3 times x minus 5 times the quantity x minus 2 over x minus 5. So we'll just copy the denominator here. And then plus 6 times quantity x minus 5 and quantity x minus 2 all over x minus 2, which is our numerator. Now, ganun na 8 naman ni siya. Because if we'll multiply this one here in 8, so as you can see, this one is just equal to this one, right? So if we'll multiply it by 8, meaning 8 times this one, so we can just divide this this expression by the denominator, and their quotient is actually just 1. So meaning the remaining will be 8 times 1 or 8. That's why we have this equation here, this one. So simplifying this equation, we can just divide x minus 5 by x minus 5, right? And that will result to 1. So meaning 3 times 1 times x over 2, which is just equal to 3 times x minus 2. And then copy the operation plus 6 and then x minus 2 divided by x minus 2 is just equal to 1, meaning 6 times the quantity x minus 5 times 1, that's just equal to 6 times x minus 5. And then equal to 8. So just copy 8. Now, we have here 3 times the quantity x minus 2 plus 6 times the quantity x minus 5 equals 8. So multiplying 3 by this equation, we'll have to distribute 3. So 3 times x, we have 3x. copy the operation minus, 3 times negative 2, that's negative 6 or minus 6. And then plus 6 times x, 6x, and 6 times negative 5, which is just equal to negative 30 or minus 30 equals 8. Now we have to combine like terms. So meaning we will operate or we will perform the operations in the terms that are the same. Meaning, so 3x here plus 6x. So 3x plus 6x. So we'll have 9x. And then negative 6 minus 30 or negative 6 plus negative 30. That's negative 36. And which is just equal to 8. So hindi ka to see 8. Now, our goal here again is to isolate x since we are looking for the value of x. So we will combine like terms still. So meaning 9x minus 36, kung saan mo na to para mabalhin si 36 dahil we will add 36 in both sides. So adding 36 here and then 36 in this side. 9x minus 36 plus 36, that's just equal to 9x plus 0 or just 9x. And then 8 plus 36 or 36 plus 8. So performing 36 plus 8, we have 44, meaning 9x is just equal to 44. And then dividing both sides by 9, we get 9x over 9, which is just equal to 1x or x. And then 44 divided by 9 or 44 over 9. So this is the value of our x, 44 over 9. And again, if we substitute x, the value of x, which is 44 over 9, from this equation, we can get a value that's equal to each other. So that's it for equations involving rational expressions. So those are our topics for today. I hope that you have learned something, and thank you for watching this video.